Hello, everyone. Hello to wherever you are around the world. We've got some attendees from across Europe, Asia, and America. I'd love to greet you in your mother tongue, but sadly my language skills are limited in English. My name's Richard Park, and I'm an electrical engineer with Threepwood Consulting. I'm currently at home here in Cheshire. Behind me, you'll see all sorts, but I've covered it up in case my daughter runs in. I'm joined by Ian and Gavin, who are getting ready backstage shortly to speak to you. So for anyone who hasn't heard of Threepwood, we are a small independent electrical power consultancy. We're based in the north of England, and many of our consultants have worked in UK electricity distribution companies. We're heavily involved in the development of electricity documentation, standards, specifications. We also are involved with electricity safety, procedures and the like, and electricity asset management, so feasibility studies, maintenance practices, network planning. We're joined today by Roxtech, the company that develops sealing solutions for cables and pipes. And Gavin is here to tell you a bit more about Roxtech and their areas of expertise. Before we get into the main event, I'd like to thank you for taking the time to join this webinar. We want to pass on our knowledge and experience of the subject so that the whole engineering community is better informed about making important decisions, engineering decisions. So let's just look a little bit more at the topics we're going to cover today. If I can share my screen. Just bear with me. We are covering some of the key topics that we've prepared in a white paper recently published that looked at internal arc and arc flash faults. We're looking at how you can reduce the risks and some of the environmental impacts. We're looking at internal arc testing and worldwide related standards and some of the hierarchy of measures you can use to prevent internal arc. So some housekeeping before we do start. We will take some questions at the end. So please use the question and answer facility to post your questions. This is being recorded, so a copy will be sent around to all attendees when we've finished in a few days. We have another event of the same topic occurring on Thursday, so once both events are finished, we will probably pick the best recording and send that one around. If you don't wish to remain on our mailing list, please unsubscribe when we send around the link. We are going to share you the contact details of both Ian and Gavin at the end, so that's a little incentive to hang around at the end. For any future events, please head to our website, threepwoodconsulting.com, or indeed you can find us on LinkedIn. So, our first speaker, I will ask Ian Naylor to come on to tell you a little bit about Ian. He is a principal consultant with Threepwood Consulting. He's a proud Yorkshireman. That's a county in the north of England, for anyone who hasn't heard of it. Ian started his working life in the coal mines as an electrician, and he's worked his way through various manufacturers and also the UK Electricity Association. He has a wealth of experience in medium voltage switchgear, and he represents Great Britain on various technical committees, including the committee tasked with updating 62271-200. This is the standard setting out internal arc type testing for switchgear. So let me get Ian's presentation up.
Good morning, everybody. Welcome to this webinar. It'll be a change to talk about circuit breakers, which are proper circuit breakers, unlike the ones that Boris Johnson keeps on about. Far more interesting subject, I think. Yeah, the topics we're going to talk about this morning are in the white paper, which Richard mentioned, and I'm going to talk about basically the main standards about internal arc around the world, which are two main standards really, the IEC 62271-200, and then in America there's the IEEE C3720.7 standard for internal arc. Just on where on the network are we talking really? We're looking at sort of catastrophic switchgear failures in a substation like this one that you can see, which I'm just showing you with my mouse there. I suppose one of the things, you'll see all these bubbles, this is where Threepwood have been involved. We've proudly been working for the Energy Networks Association since 2010, helping develop specifications and engineering recommendations all across the network. But today we're going to talk primarily about internal arc within metal enclosed switchgear inside buildings. And one of the things about standards, which most people will know, that there's many standards which are not standard. And what I mean by that is when we talk about high voltage in IEC terms, it's above 1 kV up to 52 kV on the switchgear world. In cable standards, for example, you get medium voltage, which are up to 36 kV, and medium voltage around the world means different things. In Australia, the upper end of medium voltage is 72.5 kV. In America, medium voltage means anything between 600 volts and 69 kV. So we're going to be looking at this sort of area in this substation. What I'm going to talk about this morning is not complex or difficult. It's all about keeping things simple to avoid failure. It's not rocket science. It's common sense in a lot of things, but things that often go wrong. So if we've got switchgear, it's all about what do we want with switchgear? Well, it's all about trying to keep it in the box. Simple as that. So if you imagine we've got a piece of metal enclosed switchgear, and I'm just with my cursor, you can see I'm drawing a line around there. If that's a metal enclosed switchgear compartment, and this is the switchgear within that metal enclosed box, we want to try and keep the switchgear inside. We want to try and keep the arc contained within the metal enclosure. As soon as that arc flashes across to Earth, you've got the catastrophic failure. So one way to, the main sort of safety critical type test which manufacturers do in design of switchgear is the internal arc test, and that for me is by far the most important type test because it saves lives. The rest of the type tests prove the functionality of the switchgear, but the type test for internal arc is the one that ultimately saves people's lives. So that's why it's so important for me. In -200, the IEC 62271-200, a lot of people think that all switchgear is internal arc type tested. Well, it's not. It's an optional test. It's not compulsory. If you have the test carried out to ANSI C3720.7, it is tested for internal arc. There's no doubt. And in Canada, there's C22.2 or 22-11, which also prescribes the rules for internal arc. Another interesting thing is that the SF6 switchgear is never tested internally arced with SF6 in it for environmental reasons, although it's a more onerous test in air, but that's another subject. And then the other fact about internal arc is oil switchgear cannot be internal arc rated. It just doesn't. It cannot be tested in that way, and you will see why as we go through the slides. So I'm going to show you now a quick video to show the difference between internal arc and arc flash, and hopefully this will get across. The first picture shows a successful internal arc test, and then I'll pause it halfway through. It shows the normal running speed and then slows it right down to see what happens. And there you can see, just if you look at the side of this is from the side of the switchgear with a camera looking, and you can just see, look at that flame in the middle there. That's nearly, well, it's a flame that's escaped from the switchgear, but it's not ignited the black cotton indicator. So that test proves that people can stand at the front of the equipment, side of the equipment, and at the back of the equipment safely, and it fails catastrophically with inside, and everything's contained mechanically and electrically. There's no issues, and that is a successful internal arc test. If we move on now, I'm going to show it's the same test, but the camera goes to the front of the equipment with a weakened bolt, and this replicates a door not being secured properly, or the wrong bolts being fitted or not fitted at all. And this could apply even at LV, motor control centers, doors not fitted properly when they're internal arc. Some LV switchgear is internal arc rated as well. So if you've got, you'll see what impact this is, and it also just demonstrates an arc flash event as well at the same time. So I'll let that run now onto this next part of the test. And that's your thermal energy in an arc flash, and that's when we do arc flash calculations, that's what we're calculating. Okay, I'll just move on. So let's consider some of the most important things for switchgear failure that we should think about. I suppose when we look at the type of switchgear, there's a number of things, considerations. I'm not going to read them all out there, but most importantly, the one at the bottom there is how it fails. Understanding the type of switchgear you've got and the failure modes that may occur and the failure mechanism. On the system, I suppose the criticality is very, very important. And then when we look at the history, this is an important one as well. And when we look at the maintenance regime, and a lot of people get confused with maintenance when manufacturers say it's maintenance free. They're talking about maintenance free within the main switching compartment, not the other compartments. Other parts of the switchgear need maintaining. There's no switchgear that's maintenance free. There's some type of maintenance required, and that's very important. And then on the duty, fault level, so important, related to tripping times, and that relates back to the amount of energy released, obviously, and I'll describe that again in a bit more detail shortly. And then the environment. This is really, really important. It's not rocket science. Keep the temperature right. Keep, it's just like any other thing that you look after. It needs to have the nice, good temperature. And Gavin's going to talk a little bit more about all the environmental issues and how we can protect that within his presentation. This slide is probably the most important slide in my presentation this morning, and this is about the hierarchy of risk. And this is based on UK legislation and NIOSH requirements in North America. And I'm focusing, this is aimed at duty holders and safety responsible engineers. Really, I'm just going through the steps of what are the most important things. And the most important thing for me is elimination. Get people out of the switchgear, out of the substation. If there's nobody in the substation, there's no risk to them. And that's fundamentally the key thing. If we can do that in any way, brilliant. Substitution. Now, what will be my substitution is use internal arc rated switchgear. If you've got switchgear which is not internal arc rated, then I think you should be considering replacement. Engineering controls, use of arc detection, lanyards, for example. Another good way of demonstrating engineering controls, and administrative controls, and that includes the safety rules, asking people to be outside the substation when any switching takes place. And so for the duty holders and safety responsible engineers, they should be focusing purely on those 4 levels, hierarchy of risk. And then lastly, the last thing to consider is PPE. Now in America, IEEE 1584, it's mandatory. It's mandatory to do arc flash calculations. It's not in the UK. So that's quite important. And it's a very important consideration of which compartments are covered and what, I suppose arc flash PPE is very important if you're considering equipment where live working may take place and you need to work out what an incident energy would be. I've just thrown this slide in quickly. In UK legislation about the hierarchy of risk, it says adapting to take into consideration technical progress and replacing the dangerous by the non-dangerous or the less dangerous. So if you need a good excuse within the UK, that is look at the legislation. It says it in black and white. Right, let's just have a quick look at some of the switchgear types. We've got ABB ZS1 there, and you can see this is an internal arc door. You can see how thick, it's a lot thicker than sort of some of the conventional older types of switchgear. Withdrawable type switchgear with a vacuum interrupter. This is fixed because it's got a fixed circuit breaker. It's not withdrawable, unlike the other design there. And you can see the good old vacuum bottle, which sits inside various types of switchgear now. And it's becoming more and more popular as SF6 is unpopular with environmental issues. But there's no difference. It's not rocket science. We're just trying to keep the arc contained within the vacuum bottle. So the vacuum bottle closed there, it opens, and when it opens, we want the arc to remain within, and that's well controlled with the spinning contact, 1 fixed, 1 spinning, and that extinguishes the arc. It's fairly straightforward. Now then, let's look at where are we talking about the various compartments. So this is what I used to call a cable compartment, but in IEC standards, the definition is defined as a connection compartment, basically where the cable connects, the main switching compartment and the busbar compartment. It's very important you understand which compartments are internally arc tested if you've got internal arc switchgear. Now this switchgear is not actually internal arc rated, but it just shows you the withdrawable process that it's inserted or withdrawn. An important thing to know is that in America on the C3720.7, the internal arc test is carried out in all the compartments with the LV compartment door open. In IEC, it's not, so that's something to consider. One of the things that I'm going to talk about now is oil switchgear, which I've said it cannot be internal arc tested because of the physics of how it's built and the construction. Basically, oil switchgear, when it fails, it's catastrophic, and generally it doesn't take any prisoners when it does fail. It's basically, we're talking about quite a spectacular failure mode when oil switchgear fails within the main switching compartment. And for me, there's a massive issue that if you consider this as having a car, would you drive a car now without a seatbelt? I would ask you. And if you bought a new car, would you buy a new car without a seatbelt? Because we're still making oil switchgear, the new oil switchgear, and companies are still buying it. And it can be well managed, it can be contained, but if something goes wrong, we're talking about fatalities generally with oil switchgear. And this is a slide to demonstrate that. This shows what happened in one of my old companies years and years ago in the 90s when there was a number of catastrophic switchgear failures and fatalities, all related to oil switchgear. And that you can see the size of this was a test that replicated what happens in oil switchgear when there's an internal arc. And that's the consequence of most oil switchgear. That is what we're talking about, and that's the size of a person's head there, roughly. It's just awful, and that was a result of contamination left after maintenance, probably. So, to keep the switchgear healthy, there's two real main things for me that we need to do. Again, it's not rocket science. Dielectric integrity. Basically, we're trying to keep the electrical stress between the conductor and the earth in a good state, and with the insulators, etc., and all the materials. So we're keeping the relative permittivity, those lines of stress, even. As soon as we introduce any contamination or contaminants, or the design's not fit for purpose, these lines of stress compress like a low pressure on a weather system, and then we could get a flashover, and that's brought on by severe, harsh environmental issues, which can be found in various substations or sites around the world. So if we look at, again, I'm keeping things simple on the mechanism, the circuit breaker mechanism. When the switchgear is closed, it opens. We want it to open on a nice, quick speed, no sort of stickiness or the mechanism slowing down for whatever reason. That's how we want the switchgear on a circuit breaker to open quickly and smoothly. Soon as we talk about a mechanism getting contaminated, not cleaned correctly, then the slope, the gradient of opening is slower. And what does that lead to? Well, if you don't use the right lubricants, if you don't use the right cleaning on the mechanism, and you get stiction, it can lead to the flashover. So the management of materials in maintenance is so important, and how the mechanism of switchgear is maintained. So there's two key things for keeping the switchgear in a good, healthy sort of state. And trip timing is very important. Every 2 years, I'll just throw that one in. Right, let's go back to the internal arc test. This shows what we wrote the white paper about the sealing solution, which was the cable seal at the bottom of the switchgear keeps the blast within the cable, the connection compartment. And this was carried out on ABB 36 kV safe ring, safe plus switchgear. And you can see the black cotton indicators around the whole switchgear. So it's given a full round coverage. In the bottom of the switchgear, you can see there that the cables are compressed by the cable sealing solution, and then that's awarded the report of performance to show that it was successfully tested for 25 kA for 1 second, and it was given Aflr rating. So what does Aflr rating mean? Well, once you've passed the test, there are a number of classifications. A means that it's restricted access, so this is common amongst most switchgear, that it's restricted to the workers within the utility or the industrial plant. There are other parts of the world where there's unrestricted access. This is when I was involved in a switchgear project in New Zealand, and the switchgear is actually on the pavement with no unlimited access, so that's B, unrestricted access. Not very common. Quite common in the UK is to have an AF rating where the front protection, so it's just the front and restricted access. There's one thing that's important there, is you get a pressure rise into the substation, the flame gets expelled somewhere, and it's working out which areas are covered and the impact on the building or the damage on the building. Lateral side, L, and R, the rear protection. So they get categorize this after the successful test, and you'll find that on the rating plate. Just a quick history lesson about internal arc testing. One thing, it's evolved since the early 1980s in different standards, and when it first started, it was only tested on the main switching compartment, and in about 2002, in the introduction of -200, it then said that if you did an internal arc test, it's got to be tested in the connection compartment and the bus bar compartment, as well as the main switching compartment. And now we've recently had a new standard on internal arc for overhead line equipment introduced. So these are the things that you've got to consider for different types of equipment. So if I conclude, the key things, as I keep stating, it's so important to make for me to make sure that you have internal arc rated switchgear where possible. We need to consider sealing and making sure that the arc's contained within the equipment, and we can use this via a number of means. The key thing, arc flash calculations, it's the last line of defence. Concentrate on those upper 4 levels that I mentioned. And when we've got oil switchgear, there's a good chance that there will be fatalities involved. So my recommendations, I'll look at the safety pyramid, the inverse pyramid there, hierarchy of risk. Concentrate on those upper 4 levels. Look at considering using the cable sealing solutions, which I mentioned. But fundamentally, the one thing at the bottom there is, come on, guys, we're in 2020. Oil switchgear has been around since 1940s, 50s, 60s, 70s. We've got new technology. It's not that new now, is it? 1980s. We could be having internal arc rated switchgear everywhere and saving lives. And the excuse that we can't afford it is for me, it's just not on. It's down to duty holders and safety responsible engineers to put a case forward to the business owners and justify the reason for change, because things need to change. I think that's my opinion anyway. And at that, I get quite emotive about it, as you've probably gathered. And there's our website there to take a look for more information. And I'll hand back to Richard.
Thanks very much, Ian. Excellent. And you can definitely tell Ian, this is has got a lot of expertise, and so much so he uses the that picture as his background on his Teams every day. Please, people, post any questions on the right. We haven't had any questions yet. So our next speaker is Gavin. Gavin is a sub-segment manager from Roxtec. He's worked for Roxtec for 13 years. And all land-based business areas. He is currently, well, every day puzzling lots of client requirements, a range of applications in transmission, distribution for both UK distribution network operators and private network operators. Gavin is originally from Lancashire, but he now lives in Yorkshire. He has a huge collection of trainers, and many of which are probably under his table right now. So I'm going to load up Gavin's slides and ask Gavin to take it away.
Thanks for the great introduction. So yeah, the 3 most important things in my life from Lancashire: trainers and bikes. I think you've summed me up perfectly there. So
thanks, Gavin.
But yeah, thanks to Ian for that sort of great overview of ARC and some of the considerations there. I'm going to steal something with pride from Ian, which Ian said that, this is simple, it's not rocket science, and I'm going to echo that through my presentation. Simplicity and understanding the phenomena and understanding consequences. Very often, very complex issues have quite a simple fix, and if you stick to the basics, you usually come out winning. So, I sort of live my life by that ethos, and I'll continue to sort of follow that theme within my presentation. So really what I'm looking at is I'm going to be considering some of the environmental issues or environmental impacts that Ian mentioned there as well, but I'm going to take that to a wider environment. Just a very short introduction. Some of you here today will be aware of Roxtec and what we do, but basically we're the world's leader in modular cable and pipe seals. We operate in, say, 80 markets around the world. Our solutions are at the front line of protecting life and assets. So Roxtec tends to be used where we've got a high cost of failure or a critical application. We're used from marine and offshore, nuclear, advanced facility laboratories, and obviously power being one of our most interesting and stimulating business areas. We're working all across the energy mix, like I say, generation, T&D, renewables, and some of the newer technologies that are emerging as well. But we work with clients that have this have these areas where, you know, there's a high cost of failure, and they want reliable operation, and you know, that sort of ties into the Rockstack ethos as well. So those of you that don't know, and I just spend a minute just to quickly explain how our system works before I go into some of the other considerations around environment. Ian showed a picture there in the bottom of the switchgear, the ABB test using one of our rectangular systems. But very simply, Rockstack's entire success and the entire sort of company solutions model all sits around something that's very simple and innovative, which is this notion that we term multi-diameter. So all our systems are built up of rubberized seals or modules. Just to show you very quickly, the modules work in a very simple way, which is, you know, as it sits like that on the screen, it's a spare. You can open it up, you peel the layers to fit the cable or pipe. It's dead simple, dead easy. Obviously, there's a number of different modules, but within that range, we can seal, you know, pretty much anything. Everything's within a frame, and there's a means of compression. Here, the compression is from a compression wedge specifically. So rubber seal, peel the layers, compress it together. Now, you know, what does that do for us in terms of protecting life and assets? Obviously, it covers a wide range of sins in terms of potential challenges, and that I will explain and put it into context of this environment. But, you know, just on this notion of simple and innovative, you know, we talked about the frame, modules and some means of compression. You put them together, we've got a certified safety solution for a number of different requirements. You know, if we're talking about round seals, say below ground cable entries in the substation, the frame here is a cast-in frame. Round seals, you can see a trefoil seal there, a single cable seal, or what we call an R seal, which is the one with the aperture. We put the modules in. You can do several multi-cores coming out of that, for example. But again, you put the frame with the kit, gives you a safety solution. The final area really that we concentrate on is cabinets and equipment. So similar again, a frame, some means of compression, modules, a box, put them all together, and what have we got? We've got a certified safety solution. So rectangular solutions, round, and obviously cabinet solutions. So we cover the mix. What is interesting, and certainly we talked about keeping things simple. Rockstack certainly is a one-source solution. What we cover with our systems is a range of multi-hazards. So you can see there, like fire, noise, pest prevention, gas tight, water tight, dust, explosion protection, a number of different sins. So the way I tend to try and explain this is that, you know, our solutions start at a basic IP for underground sealing without a fire rating, rodent proof, cable retention, and then we start to move up. Our standard product has all those things, but it adds into the mix of fire protection. But then when we go beyond that, we've got several advanced demand solutions such as bonding and grinding, solutions for EX rated equipment, and also a full electromagnetic shielded system for very high frequency interference. But the cool thing is that these different systems all fit together in the same way. If it's going in a rectangular frame, you know, it's just a question in 90% of applications, or certainly a higher percentage. We're talking just our simple multi-hazard, but it's where we've got these advanced demands, we may swap out the module type. But hopefully I can explain that, you know, we can cover some really cool performance requirements, all with the same ideas, thinking and technology. So, you know, one methodology, really good protection, multi-hazard, but then add on top some of these really advanced demands. So, you know, when I'm talking about substations, I always like to think about the context, and I find this fascinating to think about. If you think about the kiosk substation on the left, you know, renewables, it could be on a wind farm or a solar farm or whatever that might be. What are we talking there? We are basically talking an IP seal, rodent protection, cable retention. But on the right hand side, you've got a modular substation that would be installed on a process site, petrochem or whatever. They're essentially doing the same thing. They've got the same functions. They may even have the same gear inside the two different buildings. But what you've got is a range here of additional requirements. So where we start at the low end, we are talking water, gas, dust. We may add into that some fire. Obviously, fire becomes more complicated when we move away from basic cellulosic fires to hydrocarbon and jet fire. But then also we may want to consider advanced demands, so bonding, grounding, shielding, possibly even zoning or blast proofing. Essentially the same structure, but but in context, there's a hell of a lot more to think about as we go up the requirement scale, depending on environment of operation. It's really important for me that we think like this, that like I said, essentially the same structure, but varying demands. So Ian expertly told us or informed us today about some of the things that we should think around the switchgear operation arc related mitigation. Rocksteg's been used there obviously to help contain or direct a failure, a blast. I'm interested in just stepping slightly away from that, but talking about the wider environment. Now, in that wider environment, Ian also mentioned that the environmental condition can play a significant part in arc-related events, whether that's the smoothness of the switching or whether perhaps that's PD activity occurring due to bad environmental condition, obviously also having an impact. Just something that occurred to me then, and I'd not actually thought about it before. Ian was talking about a blast happening in the substation. Funnily enough, if calculations have been made for that overpressure within the building, those calculations may not be quite as valid if the basement of the substation is completely filled with water, because we're looking at an expansion path. Just an interesting point to note there, especially where you're looking at the actual building envelope. But I'm going to be looking at these wider environmental operating conditions, what their impact is in terms of safe operation. I always like to start my real presentation in the real world. I've been working now for 13 years for Rocksteg. And I've seen some really well constructed projects, and I've also seen some projects that are suffering from environmental ingress in quite a bad way. One of the problems that we have around this issue is that very often cable sealing is sort of regarded as low cost, low importance. I will think about it down the line. Really, it needs to be thought about up front. It can have significant impact on safety and operation. One of the other lessons that I've taken from my time in the industry is that not everyone's got a really detailed specification as to how to achieve good sealing of the building, certainly below ground. It is a working partnership between the civils guys and the electrical guys. Sometimes that can be quite difficult. They've got to agree on the best way of doing things. We've also got a number of other drivers in terms of, we want to hit the footprint on the switchgear, etc. So we sometimes get pushed into a corner in terms of how we're going to enter the building. But I would always counter that with a little bit of thought, a little bit of design planning around a reliable entry method. You shouldn't have an issue. The final point I would take in terms of this is without a doubt, the full impact of bad environmental conditions is not always known, and is certainly not always recognised and considered in the way it should be. I mean, we mentioned there in the previous presentation the real impact on arc events from bad environmental conditions. Sometimes we don't think in that lateral way to link it up. Ian mentioned make a strong safety case for replacement and upgrade. I would say make a strong safety case for building the substation in the best way and sealing it correctly, because it does have massive impact on safety and operation. So I'm going to play you another very short video clip, which I will talk over and just explain. But for me, when we're talking about badly sealed buildings, we're talking about water ingress, dust, dirt, humidity, pollutants. That has a significant impact on inception and acceleration of potential partial discharge activity on switchgear. whether that's an internal failure or treeing on the surface of materials. But what will eventually happen with this is a failure. You know, some industry experts and estimates estimate that, you know, 80% of failures or 80% plus of failures can be drawn back to partial discharge or something related to it. I would always say that that has a definite link into the environmental operating conditions. I'm going to give some insight now in terms of that, and I'll try and explain that and put that in the right context so we can understand that environmental impact. So, you know, some may argue this is simplistic. I would say that it's good because it is simple. You know, where we're looking at power outage, we've already talked about industry estimates, tying things back to switchgear failure and partial discharge. Where's that come from? Where's it accelerated, or what is it accelerated by? You know, it's definitely humidity, dust, pollutants, bad operating conditions. There are other drivers, but you know, that's a major heading that we've got to consider. You know, where has all that dust, dirt, water and pollutants come from? You know, we've already seen that. I'm sure there's people here that have seen significant ingress below ground. We've seen structural ingress. Why is the medium entering the building? You know, I'd like to offer the opinion that that's down to the fact we've inadequately sealed it. What I'm going to do is I'm going to take IEC 6227-1 as a vehicle just to talk about environmental condition. You know, the standard talks about ambient air not being polluted with gas, smoke, corrosive, flammable gases, vapors or salt. It also gives a couple of stipulations there regarding relative humidity over 24 hours not exceeding 95%, and average relative humidity over 1 month not exceeding 90. So there's two sort of types there, 24 hours and over a month. You know, driving a cleaner environment and controlled environmental conditions for good operation. The thing with the standard is that it does, within the design notes to the standard, highlight the use of what it terms control measures to manage, for example, relative humidity in the operating environment. Should also probably be considered that most, or if not all of these tests for type are short timescale, long-term effects, you know, running at near excessive, you know, might not always be known. I think with these, or with this number of unknowns, the most important thing is to do the best you can, and to do the best you can is to manage the environment in a smart way. Just moving forward from the standard, within various manufacturers' literature, operating manuals, etc., you can see a range of what the manufacturer may term optimum conditions for operation. I find these interesting and fascinating. You know, I'm not going to read each example out, but you can see in the very first one, you know, must not exceed, relative humidity must not exceed 80%. Combination of temperature and humidity shouldn't allow for condensation to form in or on the equipment. You know, where the relative humidity exceeds that 80%, you know, it's saying take precautions to prevent it. I'll pick example 3. You know, ideal conditions, humidity below 40. Standard humidity below 60. So even within the manufacturer's terms, there could be quite a significant variance, and it could be, most likely will be, below the levels of environmental relative humidity that's stipulated in the coverall standard. I think it's really important to understand the manufacturer is trying to give you the correct steer to get the best from their equipment, but just take note that those levels may be significantly lower than the standard. You know, we mentioned that control measures, and control measures are a funny thing for me. You know, if we take typically, you know, we're talking 3 standard things that I see very regularly, which is, you know, pumps, heaters, cooling and dehumidifiers, air conditioning and dehumidifiers. We've got all these things there that are playing a part to manage what, the optimum conditions for operation. But it always strikes me as a little funny when, we've got water entry or dust, dirt and pollutants entering the building through the cable ducting. My stipulation is that, reliable cable sealing is going to reduce the demands to get the environment under control. We're dealing with it as source, that is the source of all those issues. So it allows us to reduce the reliance on these control measures. Hopefully that's going to lead to better operating conditions. Well, I know it will. So I always like to just pose the question, when I'm dealing with people, what happens when the control measures fail, or, they go offline? Are you absolutely relying upon that to achieve the result? Things do break down. Another thing just to think about is, do you view those pumps in the bottom of the substation as everyday operating equipment, or should we have the mentality that they're there to be used in an emergency? Certainly know from industry experience, the number of pumps that burn out through work, 7 days a week, 365 days a year, that people sometimes do view them as an everyday operating process or necessity. I would say that if your pumps are running more than a few times a week, you perhaps need to take a very close look at the building integrity. Humidity is there out in the field. It's everywhere. But you can see here on the example, we've got pooling water on the equipment, 100% relative humidity of 5.6 degrees C. This can get out of hand quite quickly if we are not mindful and if we don't focus on that to keep things in check and under control. Optimum conditions, good conditions, good result. Bad conditions, bad result. So keep it simple methodology. I'd like to think that, if we have this way of thinking, it's a very easy sort of conclusion to make, that if we can seal a building up, a substation up correctly and reliably, we're going to reduce the structural ingress. That should allow us to manage, the ingress, the dust, the dirt, the pollutants. We know that that's in line with what manufacturers are recommending. We should see, good operating conditions, a reduction potentially in that PD activity. That's a knock-on to reliable operation, and hopefully that's a further knock-on to no outage and reliable operation. I think it's really simplistic terms, but I think it works for me. Like I said, good conditions, good outcome; bad conditions, bad outcome. Even a simple boy from Lancashire can understand that. So, if we take the left-hand picture here, if we tie that back to, the inadequate sealing, and we take the right-hand picture and we tie that up to good operation, I think we've all seen sites that resemble the one on the left, probably less so the one on the right. I mean, I've got to say, I used to use a number of these pictures to show potential clients, and it always shocked me in the early years where people had looked at it and go, wow, if only we really had that. We achieved it. It took a lot of work to work in terms of civils and electrical, get the coordination right, but you can do it. It's not that difficult with a little bit of thought. So just to conclude, the white paper that Ian mentioned is available for download on the Rockstech website. There are also a number of other informative white papers there. There's one on partial discharge, specifically looking at the environment. There are also a couple of good white papers regarding things like modular switchgear, modular substation construction, with a focus onto sort of process industry applications. But it's free to use and it's free to download. There's some good resource material there and some interesting insight that can be gained. So I would say to everybody, if you get a minute, you want to download that. But whilst you're there, have a little explore. There is some very useful information there. So only one thing left to say, which is, thank you and, thanks for your time.
Excellent, Gavin. Lots of great material there complementing what Ian had said earlier. So we now have a chance to look at some of the questions that have come up. So let's get our first question. It's one for you, Ian. Arc flash calculations. How likely to see? Are we likely to see those become mandatory in the UK? Do you think?
Well, in my opinion, I went to a conference where the main HSE inspector of the UK was there, and I asked the very question about, are arc flash calculations mandatory? And he certainly said no, providing the 4 levels in the risk pyramid are addressed. As soon as you've not addressed those 4 and there are flaws in that or whatever, then yes, you need to take action. But I don't think that the UK, and this is my opinion, it's not what my opinion is, I don't think it will become mandatory. I think we will continue to do what we've always done, taking those 4 levels into consideration, making the risk assessments appropriate and adequate, and taking into account making sure all the measures are appropriate. So, a very good question. I don't think it is. There's a lot of pressure on companies in the UK to do arc flash calculations because they're American owned. It's come from America, and there's a fundamental difference between what happens in America and what happens in the UK.
Thank you, Ian. Gavin, just checking back on the environmental and control and measures, and it seemed that you were suggesting that you could, if you had a sealed switchgear, you could just do away with control measures. Is that what you're suggesting?
Not quite, no. I mean, look, my viewpoint on control measures is they're needed. They're your insurance policy. But we don't want to be claiming on that insurance policy every day of the week. So my viewpoint on control measures is, yes, they are necessary. You know, but what I'm saying is that if we seal a building correctly, the building, not the switchgear, because obviously the switchgear won't be a completely hermetically sealed compartment, and neither should the building be. But what we would do is seal at point of entry, and that is going to reduce these uncontrolled environmental factors, water, dust, dirt, pollutants. So the control measures are still needed, Richard, but you know, it makes a lot of sense to turn down the reliance or the work that those control measures have to do to achieve optimum conditions.
Yeah. Thank you, Gavin. This is on the internal arc rating. So if gear has been designed and it complies with 62271-200 and has an IAC rating after the type test, but it hasn't been installed as per specification, how can that affect the IAC qualification?
Yeah, well, if you think back to remember the video that I showed, that just demonstrates exactly what the output is. You know, manufacturers give you good instructions as to how things should be assembled and put together, and often within the insides of the switchgear, there are often elements that are linked to the internal arc design to strengthen the blast that takes place within the various compartments. And although I've said keep it simple, it is quite complex how the mechanism within switchgear works from when there's a blast in one compartment to another compartment to another compartment, to leading to the release, wherever that release is, outside the building or inside the building. So there's a series of events that have got to happen, and if things are not installed correctly, put in properly, then there's a good chance that the internal arc classification won't work.
Yeah, agreed. This is one that maybe both Gavin and Ian can answer. So internal arc flash is what initially occurs, and then we have the pressure wave or the blast. Do you want to have allude a bit more to the blast itself or the pressure wave, Ian and Gavin? Do you want to go first, Ian?
Yeah, we've done a lot of work on this. We wrote an actual paper about the pressure blast calculation within a substation and the various materials, and it's a very complex subject because there are many changing parameters. Obviously, some manufacturers offer a solution doing computational fluid dynamic studies to work out the impact structurally on the building, and it's a very complex area, and it needs a lot of thought to the materials, obviously, that are involved, the pressure wave, and it all goes back to the energy levels, so, and tripping times. To do a complete study is quite complex because there are so many changing parameters right from the energy level and that builds up, and the subsequent blast, and how that's released, and the impact. Finds the weak spot. It always finds the weak spot, yeah, I've done quite a bit of research on this, and there's some quite, the Buncefield. I'm deviating, but in Buncefield, when there was the catastrophe there, the petroleum, the blast path followed the tree line around the edge of the site rather than concentrate on the centre of the site.
Yeah.
So, Ian, in relation to that, I know a little about blast, and Rockstack obviously, works around blast ratings, but, being around people working on blast calculations and blast dynamics, something as simple in that substation, if they've put, I don't know, say they have, equipment or boxes stored in the corner, it can have a massive effect because the calculation's based upon, the expansion path. And that's why I mentioned about the water, because if you've got a 3 meter deep basement that's 2 meters deep in water, then you're going to significantly change the way the blast behaves. Yeah. So there's a lot of different things here that need to be thought about.
The other thing was, if there's obstacles in the substation, it creates a positive feedback path, and it actually propagates the blast. So if there's pipes in front of the switchgear and other components and equipment, and if it's cluttered, then it just propagates the blast and makes it even bigger. Anyway, there's a lot of research gone into that, and it's a subject in itself.
Yeah. This question is asking about the frame.
I can take that, Richard.
Yeah. So just for the rest of the audience, this is a question asking what type of frame would be suitable for medium voltage to take cables into the 12 kV. These are single core cables into the gear. Mild steel or is stainless steel required?
It would be stainless steel. If you're looking at single core cables, you want to be careful there with obviously any eddy current issues. So there's a number of different things that you could do. There is actually ways that you can split plates in different materials, so you don't actually have a fully encompassed sort of mild steel option around the cable. Stainless steel is the easiest way to go, obviously, when you're dealing with single cores. There's also possibly sort of aluminium and some of the other materials as well. So it is, you wouldn't use a primed mild.
Ian, so you're suggesting that oil switchgear is you should get rid of it. Is oil? What is oil switchgear good for?
Yeah, I mean, oil switchgear has had its time, got its place. You can still buy it, as I've said, new, and it's cheap. But if you look at the lifetime costs of it, management of oil, the more maintenance requirements. If you look at the whole, you can buy it cheap, but over long term, over the lifetime cost. And then ultimately, are you prepared to say, well, I could have bought an internal arc rated piece of switchgear, a little bit more expensive, that's probably saved somebody's life? Or do you want to live with the fact that, well, we've bought that, something's happened and somebody's dead? Because that's what it is. Ultimately, we've lived with it, we've managed it, and we've got even now there's still a lot out on the network, but we still have this argument. We can't afford to get rid of it all at once. But people just don't understand the consequence of the impact of when that fails. Can you live with the fact your brother, your friend, has died after that? because I wouldn't.
Ian, just to echo that point there, I mean, very often, certainly in my professional experience, you mentioned it there, is that people are willing to take a purchasing decision based on, a 10%, a 20% reduction or whatever, but they do not think about operating costs, they do not think about maintenance cost, and they do not think about the cost of failure cost. What I would say is that, you said it at the beginning, the simpler you can make these arguments, the more likely that somebody's going to get their heads around it. But I am still shocked to this day that, as engineers, we can't look at a problem in that way. Very often we get drawn into a lower price, or what we perceive as a lower price, but it has big impact, doesn't it?
How do you know which switchgear is internal arc rated?
The key is on the rating plate, the plate on the front of the switchgear. That can be misleading. I have seen 2 standards quoted on there, and that can be confusing. That's the key thing. Look at the rating plate itself and see if it's got a rating, but then it's understanding when it was tested, to which compartments tested, and that's not always clear. So you have to probably come to Threepwood for some advice, or the manufacturers.
Yeah. One for you, Gavin. The control measures. So it seemed that if you seal the substation properly, you can get rid of the control measures. Is that right?
Not quite, Richard. I think it's a common question that we face. I mean, we're not prescribing to build a hermetically sealed building. It's practically impossible anyway, of traditional means. But what I'm looking at is, for me, is that we've got significant cost going into these things like pumps, dehumidifiers, heaters. It makes a lot of sense, doesn't it, that should we not turn down the challenge on those control measures? I mean, you can practically imagine the dehumidifier running white hot, trying to keep some places within some of those condition operational windows. The other thing that continuously amuses me is, smart pumps that talk to the control room. We know that there's a problem. Why do we know there's a problem? Well, the pump's telling me it's been running for the last 30 days for 17 hours a day. And when the answer to that is, well, what do you do? Oh, we just reset the alarm. We need to be focused. So in answer to your question, I would say that no, we're not prescribing to get rid. What we are doing is we are turning down the challenge on those. It makes a lot of sense for environmental condition. It's to deal with a problem at source, stop the ingress.
Thank you very much, Gavin. Ian, one for you. As AFLR switchgear is a more safer solution, the questioner hasn't seen DNOs choose this, and they seem to prefer AF. And indeed, ENA TS 4140, which you're familiar with, indicates AF. Tell us why this is, in your opinion.
Yeah, well, it's a minimum. You've got to remember this is a minimum requirement. Now, you're quite right, really. In most situations, AFLR is safer for the operator, but you've got to consider where the flame and exhaust gas goes to. And if it goes outside into an area which could be other workers, there could be public or whatever. So the specs there for a minimum, there's an option there to ask for AFLR if needed, but the minimum, and the minimum thing in the specs is a minimum plane level, and that's why it's AF. Yeah, but you've got to, obviously, when it is AF, you've got to consider the pressure rise and the subsequent impact on the structure of the building. Yeah.
Do you think it's important that operators and technicians, anybody going into the substation and operating gear are given clear instruction on closing doors properly on IAC gear?
Yeah, well, Are you on about the doors on the switchgear or the doors
Yeah.
on the substation? The doors on
Doors
the
on the
switchgear.
switchgear for a start.
Doors on the switchgear. Obviously, you've got to make sure all the proper fastenings are there. That video showed that a weakened fastening, that's the difference basically. Wrong bolts missing, doors not shut correctly. Then that's probably could be a big issue. So that's education, training, making sure everybody makes sure that the doors, as per manufacturer's instructions, are used when operating the equipment in that scenario. My opinion on doors on substations, if it's an AF rated, then it's better to have the doors open so that the pressure, it acts as a natural pressure release within the substation when the pressure wave hits the back wall as such, and it doesn't cause structural damage.
Yeah. One for you, Gavin. So we know traditionally, and as you were saying, substations do suffer from ingress and of contaminants. So what do you think a client should do if they have a legacy network with issues? Where should they start? How do they eat the elephant?
I was going to say knock it down. No, you've got to take a modicum of sort of reason. You know, I think working with some pretty decent companies out there in the UK, you know, some are taking a very practical view to rejuvenation of substations, whether that's, you know, upgrading and whatnot. And, you know, some of those projects, they've been able to achieve, I'm going to say, a really amazing level of build just by some simple rejuvenation when they're replacing gear, etc. On the opposite end of that, you know, the legacy operating sites, that most of the issues that I see are down to construction, and you know, there's only so much you can do. But you know, what would I say is the approach is to really get to the crux of the matter. Look at the structure. You know, with us, what we do is I think we spend perhaps someone would say too much time, but you know, it's learning time. We spend our time on site looking up to our knees in water, looking at how to fix these problems in a retrofit perspective. I think, you know, if it really is critical operation and you need to go back and retrofit, it's going to cost, but it can be done. So I would just say, you know, if you're facing that legacy issue, you know, consult with a decent company and think about how that you could perhaps retrofit fix it. I think I would estimate probably 7 out of 10 can be fixed relatively easily. The other 3, please don't phone us.
Yeah, thanks Gavin. Ian, this is on SF6 switchgear. Any views on if you're going to replace SF6 gear with a vacuum equivalent?
Yeah, I would suggest that there's a number of options that manufacturers are developing at the minute with alternative gases, environmentally friendly gases. They've all got various trade names. The one that I think looks like a good type of solution, and I need to look more into this, we've done a recent project on it, is actually compressed air with vacuum bottles, particularly at 33 kV where there's a gap in the market. That's one of the, but again, when you start looking at that, there are new failure modes that we've got to start taking into consideration, even with the new gases. You know, just because it's a different gas, it's a bit like the vaccine. Will it work? Will it won't work? What's going to happen in a few months, few years time? So there's a lots of considerations. But I have been attracted to the compressed air solution. Looks a good,
yep,
easy to manage solution.
Another one for you, Gavin. Just to guess a bit more detail on the cable compartment and preventing condensation. So as you're preventing condensation in the cable compartment and trying to maintain an effective seal against internal arc release, how to achieve those two together? So preventing condensation but maintaining effective seal.
Yeah, I mean, you know, the Rockstack is part of the strategy, if you will. So, you know, in terms of the solution that was shown in test, predominantly there, the Rockstake solution, regardless of which of the options that we would choose, we showed perhaps 1, 2, 3, 4, 5 different types of module there. All those solutions there are pretty much blast resistant. So, we are tested as, when we talk about mitigating blast, the seals in the walls will mitigate blast, and the system is blast approved, not just impulse testing, but actual live medium testing as well, so live gas explosion tested. So the system, is part of the complete build for that blast protection. In terms of preventing condensation, if we're talking about the structure, obviously, what are the drivers for relative humidity? Well, it's moisture, isn't it? Number one, you've got natural relative humidity in the air, which is, what I'm saying with the dehumidifiers. You need something there, and that's why I was saying don't get rid of all control measures. But ultimately, I'll tell you, probably a good illustration is that, we'll go into a building and we'll see a metre of water in the trench, yeah, and we'll go to the next building and, they've only got 10 millimetres of water in the bottom of the trench. To me, they're just as bad as each other. The potential for relative humidity comes from the surface area of the water. So regardless of whether it's a centimetre or a metre, it makes a lot of sense to be able to say, right, let's just stop this at source, because that is the source for, obviously, when we start bringing into that heat, etc. We've got a higher potential to cause a greater relative humidity.
Yeah. Folks, we are out of time. We've missed out a few questions there, but if you have a burning issue on your mind, then please do send us the questions. Ian's details are up on screen now, and Gavin's details. They'll be ready to answer your call 24/7, not your call, your email. As I say, we've recorded this session today. We will send you a link so you can download this video and play it to your heart's content. But in the meantime, on behalf of Gavin and Ian and myself, I'd like to thank you for your attention. I hope you learned something, and we would like to invite you to future events. So stay tuned and take care.